Okay, so I'm going to do some problems from section 2.4. I'm going to try to do 45, 46, 49, 51, and 59. We'll see how far I get. This is the conditional probability. The probability of A given B is the probability of A intersect B over the probability of B. This follows from, okay, if both happens, well, first I figure out the probability of B, and then I figure out, okay, the probability of A given that B happens. And then this is a form of Bayes' laws that we'll also take a look at. The probability of A given B, we kind of switch the script, knowing the probability of B given A. And now we figure out the total probability. I kept it simple here because I ran out of board space. So we have B and B complement to be the total probability, and that will give us our formula. So first of all, we'll read the first problem, and we'll switch our orientation here. And so we have a population, a particular country, consists of 3 ethnic groups, belongs to one of the 4 major blood groups. This is the joint probability table, and that gives the proportion. So we're asked to find the probability of A. Well, the probability of A is just everything in its column. So 0.106 plus 0.141 plus 0.2, and that gives us 0.447. The probability of the ethnic group then is part C, that's row 3. And so we just add up all those probabilities, plus 0.2, plus 0.065, plus 0.02. And if I do that, I get 0.5. And again, this is the probability of ethnic group 3 is selected. And I wonder if that looks a little bit better. All right, so let's try probability of A intersects C. Well, the probability of A intersects C is just column A and row C, and so that would just be 0.2. But now let's kind of put it together and to go to probability for part B, the probability of A given C. Well, this is the probability of A intersects C over the probability of C. We know that the probability of A intersects C right here is 0.2, or right there is 0.2, and I calculated the probability of C as being 0.5, and again, that would be all of row 3 if I just added up all these parts of row 3, and so my final probability is 0.4. Now let's try the other one. Let's try the probability of C given A. All right, so now we're in this column here, and we're going to choose this part. So it's going to be 0.2 over the probability of A. So again, the probability of A intersects C over the probability of A, because we're given A to be true. Again, we get 0.2, and we get 0.447 for the probability of A. And if you calculate that, for some strange reasons, it's the same. I think that's just a coincidence and not anything special. All right, then let's now go to, so let's kind of explain what these contexts mean. So the first one is, given someone from ethnic group 3, what's the probability that they have type A blood? Whereas this one is, given somebody from type A blood, what's the probability they're from ethnic group C? So finally, let's look at the last one, and that's part C. And here we're going to get into a Bayes theory problem. If the selected individual does not have type B blood, what's the probability that he or she is from ethnic group 1? So what we would have then is the probability of ethnic group 1, let's just represent that by E1, given that they don't have type B blood. So we'll call that B complement. So this would be, again, the probability of E1 intersect B complement all over the probability of B complement. So this is going to be a sort of a Bayesian approach. Okay, so we look at E1, which is ethnic group 1, but not in B. So we're going to add in all of the other parts, and so this would be 0.082 plus 0.106, not B, 0.004, all over the entire probability. And what we could do is just do 1 minus 0.082 plus 0.018 plus 0.65. And what I'm doing here is I'm figuring out right here the probability of B. And what I've done is I've gone down this column to figure out the probability B, and then I can subtract it. So what I get is 0.192 over 0.909, and I get a 0.211 probability. So again, just in reverse, I want everything that's not in B complement in this row, so I added up all the other type bloods, O, type A, and type AB, and the denominator I wanted probability to be complement, and so I just took 1 minus the probability of B, which would be 0.211. All right, let's go to and look at number 46 now. And I encourage you to pause your video as we look at this and try to answer them before I give them. Suppose all the individuals, individuals randomly selected from the population of all adult males in the United States. Let A be the event that selected individuals over 6 feet in height, and let B be the event that the selected individual is a professional basketball player. Which do you think is larger? Probability of A given B. Well, the probability of A given B is the probability that I is over 6 feet given an NBA player. I think that's pretty high because pretty much everybody in the NBA is over 6 feet. Maybe not Stephen Curry. He's probably lying about his height. But that's going to be pretty high, whereas people like me, who given them that they're 6 feet are playing the NBA, is actually going to be pretty low. Because even though I'm over 6 feet, I am too slow, don't play defense, am soft, probably too old, all those things. So I'm not playing the NBA. So this one would be higher because we've cut it down to a very select group of people, and we're trying to figure out what's the probability that they're over 6 feet. Let's go on to number 49. And this is a table that gives us an information about type of coffee selected by someone purchasing a single cup at a particular airport kiosk. And so, 34% drink small, 30% drink medium, 36%, and we can go all the way across this way. And let's go ahead and set that up. Actually, I set it up here. So 0.14 plus 0.2 is 0.34, which I guess, that's the probability that people drink coffee. 0.2 plus 0.1, 30% drink medium, and 36% drink large. And if you go across here, this gives you that 60% drink regular, and all those up, you get 0.4. So the question is, what's the probability that the individual purchased a small cup? Well, a small cup then would be 0.34. So for A, we would have 0.34 as one of the answers. That's the probability of drinking a cup A. I just purchased a small cup, probability of S, I guess. That's not a script of S. And then what's the cup of decaf coffee? Adding those across, the probability of decaf coffee is 0.4. And so these tables help you figure out these probabilities. And then if we learn that a selected individual purchased a small cup, what is the probability that she chose a decaf coffee? So what we want is the probability that someone selected a small cup. What's the probability that that'd be decaf? Well, if they're in a small cup, they're in this sort of area right here. And so given that they purchased a decaf, we would have the probability of D intersect S over the probability of S. And that would then be equal to 0.2 over 0.34. You could kind of think of this as, okay, in this column I've got 2 out of all the sum, so 0.2 over 0.34, and if I calculate that I get 59% chance or 58.8% chance for that. The second, or part C, if we learn that the selected individual purchased decaf, what now is the probability the small size was selected? All right, so this next question is in reverse. Suppose that we know that they purchased a decaf. What's the probability they took a small guy? Now, I don't drink coffee. I may not be a good Christian because I don't. But I know that people who drink decaf do not drink them in large quantities, so this may have a say. So again, what we do is we look at this row here. This is all the probabilities of decaf, and then here's this probabilities of small. So what we do is take 0.2 over the total, and so then there's a 50% chance. And so these are not the same, in part because there are a little bit more people that drink regular, and you can kind of compare what those two work at. I'm going to pause, and we will try the next video for the next few problems.